All right, y'all, now I'm going to clear the annotations. Boom, I'm going to take us to example 3. Okay, so that's what we got here. How many examples are on these notes? Yep, that's a lot of examples. Okay, here we go. And now what I'm going to do is I'm going to talk about this. So this is example number 3. The first thing I'm going to do whenever I have something like this and I see something on the bottom I can factor, I'm going to factor. So this is one of those weird things that's like, okay, man, this is a lot, but just watch. So the first thing you're going to do when you see a problem like this, remember, we want bigger fraction bars because we're going to be doing some mess on here. So this 6x minus 6, I'm just going to keep right now in its form. I don't care what to do with it. But this bottom one, this is x squared, which is a perfect squared. This is a minus, and this is a perfect square. So y'all should have this down by now. So that ends up being x plus 2, x minus 2. You see that? How did I get that? What's the perfect square of x squared? The square root of x squared is x. The square root of 4 is 2. Check it out. X, 2, 2. So that's the rule. Perfect square minus perfect square. You can break it up like that. All right. Now I'm going to do my 12, and then I'm going to write my x plus 2. But check out what happens here. What's my common denominator? Before you start multiplying things over and over, look at the left side. I have an x plus 2, and I have an x minus 2. Look at the right side. I have an x plus 2. I'm only missing one thing. The only thing I'm missing is that x minus 2. So add that x minus 2, and suddenly you have a common denominator. But look at the top. If we put it on the bottom, you got to also put it on the top. That's just the deal. So this is awesome because now we can basically ignore the denominator. The denominator is gone. We don't care anymore. Again, that's not exactly accurate, but it's close enough for what we're doing. And so it's like if you don't understand this part yet, don't worry about it. Just be cool with it. And now what you have is you have 6x minus 6 equals, I'm going to distribute. 12 times x is 12x. 12 times negative 2 is negative 24. I'm going to subtract 6x on both sides because I want to get everything. Oh, now this is not x squared, so we want to get x's on one side and numbers on the other. So don't forget that. This cancels out. I get negative 6. 12 minus 6 is 6, and then minus 24. I'm going to add the 24 on both sides. I'm going to add the 24 on both sides, and I end up with 18 equals 6x. When you divide that out, divide that out, you will end up with x equals 3. So for one of our solutions, or for our solution, we found x equals 3. Now you know the drill. You have to go back to the original equation, and figure out what the denominators can't equal to. So the first one is easy. The first one is x plus 2 cannot equal 0, which means x cannot equal negative 2. So I just moved it over. Boom, it cannot equal negative 2. Now we got to take this side over and put it over here. So I'm going to move it over, and we're going over this way. Here we go, y'all. We're going here. Now I have to go x plus 2, because I'm factoring it, x minus 2. The good news is, and then I have to set both of these equal to 0. But check it out. We've already solved for x plus 2, so we know we don't have to do that. So I don't have to worry about solving for this one. But x minus 2 equals to 0. Then x equals 2. So we can't have what's going on there? X equals 2. So in this case, x cannot equal 2. And that's just the extra thing on the denominator. And if you're confused on any of this stuff, it doesn't matter. Like, this is literally the culmination of everything you've learned. You should be a little confused. But you need to just buckle down and get into it. So that's that for number 3.